Okay, now that we've introduced these four kinematic equations, let's talk about some of the how to use them and some of the key words and key terms that we might find in a problem. So first off, I mean this first one here we can use whenever we have initial velocity, final velocity, acceleration, and time, or we have three of them and we're trying to find the fourth. The second one, if we have a displacement, initial velocity, acceleration, and time. The third one, starting velocity, a final velocity. So starting velocity, final velocity, acceleration, and displacement. And the fourth one, a displacement, a starting velocity, a final velocity, and a time. So no acceleration. Um, and let's talk about some key terms that we might find in these in word problems. So if we hear at rest, or like starting at rest, or if we hear from rest, or if we say that something is maybe dropped as well, it's implied that it's dropped from rest. All of these mean that the initial velocity v naught x is equal to 0. Or, we can actually redo all of these equations. All of these equations can be written in the y direction as well. This is for any one-dimensional motion with constant acceleration. So I could have just as easily said vy is equal to v naught y plus ayt. And we could have replaced all of these x subscripts and these kinematic equations here with y subscripts as well. So if it's something starts at rest or something starts from rest or it's dropped, we could say here v naught x is equal to 0 or v naught y is equal to 0. The starting velocity is equal to 0 if we see these terms. If we have here something comes to a stop, so comes to stop or comes to rest, these would mean that we have our final velocity in the x direction is equal to 0. Or we could say here the final velocity in the y direction is equal to 0. And there's actually another one. If we're looking for the maximum height of something, let's say we have an object that is thrown upwards, like some sort of ball that's thrown upwards or something, and it reaches a maximum height and comes back down. What we define to be the maximum height is where it momentarily stops. And so if we see a max height, maximum height, this also implies that our final y velocity, vy, is equal to 0, or vy at the top. This is assuming that we started the clock, down here when we threw it, and we're stopping the clock up here, so our final velocity is equal to 0. We define the maximum height to be where the y velocity is temporarily equal to 0. We also have, if we see constant velocity, and constant velocity implies that, well, delta v is equal to 0, right? Which means that our acceleration is equal to 0 as well. So if we see constant velocity, it means that the acceleration is equal to 0. This becomes increasingly important as we move into later chapters. So constant velocity, acceleration equals 0. We also, if we're asked to find how long something takes, so how long, this is referring to a time, find the time. If we say how fast, this is referring to speed, which is the absolute value or the magnitude of the velocity. So find the velocity and find the magnitude of that, and we'll have the speed. If we ask how far, this is asking for the displacement, which is actually, we have to take both the x and y into consideration. So we'd say here, this is displacement. And so this is equal to the square root of your delta x squared plus your delta y squared. So let's say that we had, I don't know, something thrown off a cliff, and we say how far away does it land from the highest point of the cliff. We would be looking for this displacement right here. But we might say, we might also ask how high is the cliff. That would suggest like how far is the y direction. So how high would be just delta y. If we said how far from the base of the cliff, so the ground is over here, how far from the base of the cliff, we'll just be looking for delta x. So we could put some limiters on, our how far, like how high would be looking for delta y, and how far in the x direction, or how far from the base of the cliff, that would just be delta x. But these are the main keywords that we find in problems, applying the kinematic equations to them.